Good day, everyone. I am Rihanna Jaisal M. Tejeros, and I am the first reporter of the Group 7 Rene Descartes. So we are going to discuss about apportionment in fairness and apportionment in introduction to voting. So let's tackle about what is apportionment. So as you see here, apportionment measures the population so that seats in the US of representatives can be correctly apportioned among the states. So the reference of this apportionment is in the description box. So it is a method of dividing the whole into various parts. Apportionment is the action or result of apportioning something, an exercise in apportionment of blame. So, the determination of the proportional number of members such as state stands to the House of Representatives based on population figures. So, apportionment has been initially introduced in the US as early as 1790, when it required its representatives to be apportioned among the several according to their respective population. Since the first apportionment in the US House of Representatives in 1790, there are various methods used in determining how many voters would be represented by each member of the House. So the two most common methods that are widely used are Hamilton and Jefferson plans. So indeed, apportionment in the US traces back to the Constitution 1790, aiming to allocate representatives based on state populations. The Hamilton method proposed by Alexander Hamilton and Jefferson method introduced by Thomas Jefferson have been key approaches in distributing House seats, each employing distinct principles in the allocation process. So, these methods reflects the historical intricacies of representatives in the US House of Representatives. So, the Hamilton method nga, ito yung method na inintroduce ni Alexander Hamilton na ginamit as standard divisor quota and considers to be the largest decimal remainder. So, the Hamilton method devised by Alexander Hamilton, nag-i-involve siya ng key elements such as the standard divisor nga, quota, and consideration of the largest decimal number. The standard divisors determined by dinidivide ito total population by the number ng representatives to be apportioned. So, yung method na ito ay nag-e-employ as a systemic approach to ensure a fair allocation of seats in accordance with population figures, reflecting Hamilton's contributions to the foundation of apportionment theory. Standard divisor is derived from dividing the total number of population by the number of people to apportion. Standard quota is yung standard quota, ito yung whole number part of the quotient of population divided by the standard divisor. So, we have here the example 1. Suppose a fictitious country, Asia, which consists of 13 states with a total of population of 42,000 needs to apportion 45 representatives. The population of each state is represented in the table at the right. So, find how many members will present each state. In this example of the fictitious Asia with 13 states and the total population of 42,000, the standard quota is the whole number part of the population divided by the standard divisor. So to calculate the number of representatives for each state by the standard divisor and take the whole number part of the quotient, so this process ensure a proportional allocation of representatives based on the population of each state. So I am done reporting, so let's proceed to the next reporter.
So, good day everyone. My name is Ken Luis Cruz, and for today, I will be giving you or providing you some brief discussions about the Jefferson's method. Jefferson's method divides all populations by a modified divisor and then rounds the results down to the lower quotas. Sometimes the total number of seats will be too large, and other times it will be too small. We keep guessing modified divisor until the method assigns the correct total number of seats. So, dividing a larger numbers divisor will make each quota smaller, so the sum of the lower quotas will be smaller too. And it is easy to remember which way to go. The first step of Jefferson's method is the same as the Hamilton's method. They find the same divisor and same quota, and cuts off the decimal parts in the same way, giving a total numbers of representatives that is less than the required total. So here I will be giving you some summary of Jefferson's method. We have the number 1, find the standard divisor. Number 2, pick a modified divisor that is slightly less than the standard divisor. 3, divide each state's populations by the modified divisor to get modified quota. 4, round each modified quota down to its lower quota. 5, find the sum of the lower quota. 6, if the sum is the same way as the number of seats to be apportioned, you are done. If the sum is too large, pick a new modified divisor that is larger than that. And if the sum is too small, pick a new modivisor that is smaller. So I'll be providing you an example on how to solve using the Jefferson's method. And we begin as we also did with Hamilton's method by finding the quotas with the original divisor, which is the 21,900. So here's the result. But we need 41 representative, right? And this divisor gives only 40. We must reduce the divisor until we get 41 representatives. So let's try another divisor, which is the 21,500. So as you can see, the results gives 41 representatives. So we're done. If we had fewer than 41, we need to reduce the divisor more. If we had more than 41, we need to choose a divisor that less than the original but greater than the second choice. And that's all. Thank you.
So good day everyone. My name is Lorraine Garcia. So today I will report about Webster method. So Webster method, or Daniel Webster 1782-1852, proposed a method similar to Jefferson's method in 1832. It was adopted by the U.S. Congress in 1842 but replaced by Hamilton's method in 1852. It was then adopted again in 1901. The difference is that Webster's rounds the quotas to the nearest whole number. So rather than dropping the decimal parts, if that doesn't produce the desired results at the beginning, he says like Jefferson's to adjust the divisor until it does. So in Jefferson's case, at least the first adjustment will always be to make the divisor smaller. So in Webster method, it does not always the case with Webster method, or rather than This is not the case of Webster method. To apply Webster method, first we determine how many people each representative should represent. Do this by dividing the total population of all the states by the total number of representatives. This answer is called the standard divisor, or this is called our standard divisor. Second, divide each state's population by the divisor to determine how representatives it should have. So record this answer to several decimal places. This answer is called our quota. So third, round all the quotas to the nearest whole number, but don't forget what the decimals were. So add the values, which can be called the initial allocation or initial apportionment. The fourth is if the total from step 3 is less than the total number of representatives, reduce the divisor and recalculate the quota and allocation. If the total from step 3 is larger than the total numbers of representatives, increase the divisor and recalculate the quota and allocation. So continue doing this until the total in step 3 is equal to the total number of representatives. The divisor we end up using is called the modified divisor or adjusted divisor. So that's the fourth step to adding the Webster method. So let's take a look at our first example. So the legislature in the state has 44 seats. We want to apportion these seats to the 5 countries below rather. So using our Webster method, we want to begin by finding the standard divisor. So we find the sum of all the populations, which is 1,582,000. We divided this by the number of seats, which as 44, giving us the standard divisor of 35,954.5455. So to find the quotas, we take each population and divide it by the standard divisor. So which I've already done to save some time. But let's go ahead and check at least one of them. So to find the quota with approximately 18.152, we would do the same for the 4 remaining countries. And then now, for Webster method, for the initial allocation, we'll round the quota to the nearest whole number. So if we have a 5 or more in the tens place value, we'll round up. 4 or less, we round down. So for our first quota, we would round down to 10. So the next one is the second quota. We would round up to 14 because of the 6. Here we would round down to 7, and also here we round down to 5, and here we round up to 8. And now we find the sum and compare it to 44. So if it is 44, so we're done. And if it is not, then we have to adjust our divisor. So here we lock out because this total is 44. The number of seats that we have to apportion, we are done our initial allocation as out more final apportionment.
Hi, I am the next reporter for today's video, and now I will be discussing about the Huntington-Hill apportion method. This method is based on the apportion principle, and it is called as the method of equal proportions. The initial procedure is the same with the other apportionment method, finding the standard divisor first. The next step involves rounding up and rounding down the quotient, upper and lower quota, then finding the geometric mean. If the geometric mean is greater than the standard quota, round down the geometric mean to get the number of representative. On the other hand, if the geometric mean is less than or equal the standard quota, round up the geometric mean. To illustrate, referring to example 1 with standard divisor of 933.33, total population number of representative to be apportioned, find the upper and lower quota based on the standard quota of each state, and solve for each geometric mean. The upper quota is the standard quota rounded up to a whole number, while the lower quota is standard quota rounded to a whole number. Next step is to compare the geometric mean with the standard quota to get the number of representatives to be apportioned per state. If the total number of representatives is not equal to the required number, the standard divisor should be modified. Look at the table below. Example is number, state, population, quota, upper quota, lower quota, geometric mean, and number of representatives. So, example here is Ascoboli. The population is 3,800 total population. Para makuha yung quota niya, you need to divide the population and standard divisor, which is, yung standard divisor is given na, which is ito, 933.32. So, you need to divide the 3,800 divided by 3,800 divided by 933.33. That will give you a total of 4.07, which is, eto na siya, 4.07. Ito sa standard divisor. Para makuha yung upper quota, you need to round up yung 4, you need to round up into 5. And yung lower quota naman is, you need to round down. Di mo na kailangan i-round down kasi 4.00 na yung nandito. Is, copy mo lang yung 4. Then, geometric mean. Para makuha yung geometric mean, you need to solve square root of 4 times 5. That will give you a 4.47. So, nandito na siya 4.47. So, para makuha yung number of representative, i-round up mo lang siya dito, population, round up, i-round up mo lang siya dito. 4, copy mo lang yung 4, and then 2.68, i-round up mo into 3. Tapos round up din ng 3.38. And then, i-total mo lang lahat yung population, and then standard divisor, upper quota, lower quota, geometric mean, and apportioned number of representatives. That will give you a total dito sa baba. I-total mo lang lahat para makuha yung lahat ng total.
So, good afternoon, sir. My name is General Begani. Introduction of voting. One of the basic rights that people in democratic country enjoy is their ability to choose their leader through voting. This is a formal expression of preference for candidate for office or for proposed resolution of an issue, which generally influence decision making. So, Methods of voting. Plurality method. Each voter votes for one candidate and the candidate with the most votes wins. The winning candidate does not have to have a majority of votes. Over 50% of number of voters. In case of tie, a special runoff election may be held if votes are ranked. The candidate with the greatest number of first place votes is declared as the winner. So there are two types of plurality with elimination method without rank and plurality with elimination with rank. So this is the example of plurality with elimination method without rank. So this is my example of plurality method with elimination or with rank. So same example, A is for Ibanez, B is for Nash, C is for Sagayo. And ibibilang to natin lahat dito yung voters, which is meron tayong total of 50 votes. So kailangan natin makuha yung majority or more than 25 votes para siya yung manalo. So yung gagawin natin is sino yung mababang votes is i-eliminate natin, which is si Sagayo. Like ito, Sagayo. I-eliminate natin. So yung papalit sa second place is si Ibanez. Aakyat siya dito. So ito, i-erase ko na. Kasi wala naman third place. Kasi na-eliminate naman si Sagayo. Bale, dalawa na lang sila nagbabakbakan. So si Nash, meron siyang 21 votes. Si Nash. 6 plus 13 equals 19. So ito, si Ibanez dito sa second place, aakyat siya, papalitan niya si Sagayo. Kasi na-eliminate naman to, tapos siya nasa second place. So, aakyat siya dito, which is magiging 29 votes. So, siya yung manalo. Siya yung nanalo because nakuha niya yung majority, more than 25 votes. That's all. So, Borda count voting method. Borda count is voting method named after Jean Charles de Borda, who developed the system in 1770. In this method, 2 points are assigned to candidates based on their ranking. 1 point for the last, 2 points for the second to the last, and so on and so on and so forth. The points value for all ballots are totaled, and the candidates with the largest points total is the winner. So, board account, this is my example of board account voting method. A camping club is deciding where to go on their next trip. A is for Arches, G is for Grand Canyon, Y is for Yosemite, Z is for Zion. So, as what I said earlier, first choice is merong 4 points, second choice merong 3 points, third choice merong 2 points, and 1 point for the last. So, hahanapin natin yung Arches, yung total votes niya. So, yung 4 points dito, for example, meron siyang 9 votes dito sa first choice. Ita times natin into 4 yung 9 votes. So, 9 times 4 equals 36. 6 times 4 equals 24. So, yung gagawin natin ngayon is hanapin natin, i-compute natin kung ilang votes siya meron. Yung Arches. So, second choice, meron siyang 4 times 3. Hanapin natin. 4 times 3 equals 12. So, 5 times 2 equals 10. 10 times 2 equals 20. 12 times 1 equals 12. So, yung gagawin natin, i-add to natin lahat. 36 plus 24 plus 10 plus 20 plus 12 equals 114 votes. So, hanapin natin ngayon yung Grand Canyon. Grand Canyon, meron siyang sa first choice, 5 votes, which is 20. Kasi ita-times mo natin into 4. Kasi 4 points man first choice, second choice 3 points, third choice 2 points, and last 1 point. So, second choice, meron siyang 10 votes, which is times natin to 3, 30. And sa third choice, times natin to 2, meron siyang 12 times 2 equals 24. Dito naman, 4 times 2 equals 8. 8 to guys, 8. Hindi 12, 8. So, dito naman, 9 times 2 equals 18. Dito naman, 6 times 1 equals 6. So, add natin ulit yan. 20 plus 30 plus 24 plus 8 plus 18 plus 16 equals 106. So, Yosemite naman yung hahanapin natin. 12 times 4 equals 48. 5 times 3 equals 15. 9 times 3 equals 27. 6 times 2 equals 12. And 4 times 1 equals 4. And 10 times 1 equals 10. So, 48 plus 15 plus 27 plus 12 plus 4 plus 10 equals 116. So, ngayon, nahanapin din natin yung sa Zion. 4 times 4 equals 16. 10 times 4 equals 40. So, dito sa second choice, meron siyang 3 points, which is meron siyang 12 votes. Tatimes natin ulit sa times 3, meron siyang 36 votes. 36 points. Dito naman, 6 times 3, 18. And 9 times 1 equals 9. So, bibilangin natin. 16 plus 40 plus 36 plus 18 plus 5 plus 19 equals 124 votes. So, Zion is the winner. Zion is the winner. That's all. Thank you.